Leaving Cert Higher Level 2019, Paper 1, Question 5. So this is the complex number question from 2019, and in part A it says here 3 plus 2y is a root of z squared plus pz plus q equals 0, where p and q are real numbers and I squared of course is equal to minus 1. Then it says find the value of p and the value of q. So this is a quadratic equation with real coefficients. So the coefficient of z squared here is 1, the coefficient of z is p, but we're told that p is a real number here, and this constant is a real number, and this obviously 0 is a real number as well. So we're told here that 3 plus 2y is a root of that. Now, because that equation is an equation with real coefficients, we're going to say here as well that 3 minus 2y is a root. And that will help us then to get the values of p and q. So the first thing we'll say here is, we'll say that since the equation is 1 with real coefficients, any complex roots will occur in conjugate pairs. Alright, so for that reason, we can say that 3 minus 2y is also a root, because that's the complex conjugate of 3 plus 2y. That's the conjugate root theorem that we're using there. So, now, how will we use that to get p and q? Well, this equation is the one that we're dealing with here. So z squared plus pz plus q is equal to 0. That's a quadratic equation, and the coefficient of the z squared term is 1. So we can say that it's written in the following form. It's written in the form z squared, just leave this over here, so yeah, we can say it's in the form z squared minus, I'll put the square in there in a second, so z squared minus the sum of the roots times z plus the product of the roots is equal to 0. So we can write any quadratic in that form, as long as the coefficient of the z squared or x squared term is 1. Every quadratic can be written in this form. So I know that the sum of the roots in this case is not going to be p. If that was minus p, then yeah, the sum of the roots would be p. But in this case it's going to be minus p, because minus p then would give me plus p. So I know now that the sum of the roots in this particular case, the sum of the roots has to equal minus p. And I also know as well that the product of the roots has to equal, in this case, q. So we're now going to be able to use this information to get p and q. So I know what my two roots are. They're 3 plus 2y and 3 minus 2y. So we know that when we add those together, we're going to get minus p. So 3 plus 2y plus then 3 minus 2y, I know that's got to equal minus p. So then the 2y's are going to cancel here, so 3 plus 3 is 6. 6 is going to equal minus p. Let's bring this minus p over here, make it plus p. Bring the 6 over to the right hand side and make it a minus. So p has to equal minus 6, and there's p found. One of the things that they were looking for. Now we're going to use the product of the roots, the fact that the product of the roots is equal to q here, to get q. So again, the product means when you multiply them. So when I multiply my two roots together, I know that has to equal q. So 3 plus 2y multiplied by 3 minus 2i, that has to equal q. So multiplying this out then, 3 by 3 is 9, 3 by minus 2i is minus 6i, 2i by 3 is 6i, and 2i by minus 2i is minus 4i squared. That's going to equal q. So my 6i terms here are going to cancel, and I squared, like as we saw earlier, is the same thing as minus 1. So 9 minus 4 by minus 1 is equal to q. So 9, that's going to be plus 4 is equal to q. So that of course means that q has to be 13. And that is q found. Alright, and that's part A completed. So B part 1 here says v is equal to 2 minus 2 root 3i, and it wants us to write v in, well, this form here, polar form, where r is a real number and theta is between 0 and 2 pi. Well, so they're asking us to write it in polar form. So the first thing you should do if you're writing a number from rectangular form, which is the way this is at the moment, into polar form, is to draw an arcane diagram of it, even just a rough one. So let's do that. So if I draw my real axis and imaginary axis, there's my imaginary axis, here's my real axis. Let's just draw a quick diagram of this. So let's just scale it here roughly. So 4, let's go 4 minus 4, and 4i on the imaginary, and minus 4i down here. So 2 minus 2 root 3, you see, we need to know roughly how big 2 root 3 is. So 2 root 3, well, if you put it into a calculator and get it as a decimal, so it's an irrational number, but rounded to 2 decimal places, that's approximately 2 minus, it's going to be 3.46i. Now, so then to locate that, we're going to go, this is again the real axis here, and this is the imaginary axis. So we're going to go then 2 on the real axis, and then down by 3.46 on the imaginary axis. So we're going to be down to roughly somewhere here. So that is where v is going to be. So there's two things we must get here. We've got to get the modulus r and the argument theta. The modulus, all that means is how far the number is from the origin. So our job, we need to get the length of that red line I've just drawn there. And we need to get the argument. So the argument is the angle that the modulus makes with the positive real axis going usually anti-clockwise. And because theta here is an angle between 0 and 2 pi, we will be working anti-clockwise here. So we've got to get two things. We've got to get modulus r and this reflex angle theta. So that's what we've got to do here. So this is going to involve a bit of trigonometry. So let's, doesn't matter which one we get first here really, but I'm going to just imagine this right angle triangle here. So let's draw it separately out over here. So if I draw, it's going to look something like this. Now I'm going to call this angle in here alpha. So that's my alpha there. Now, so the reason this v is where it is because we went 2 on the real axis and then down by, well, 2 root 3 on the imaginary axis. So the length of this side here is 2. And the length of this side, ignore the minus, its length is 2 root 3. So what we can do here, we can get there's enough information in this triangle now to get alpha. I mean, because it's a right angle triangle, I can use the definition of well, I'm going to use tan in this case because I have the opposite and the adjacent. So I'm going to say here that tan of alpha is the opposite, which is 2 root 3, over the adjacent, which is 2. So my 2 is going to cancel there. So tan of alpha then is equal to root 3. That of course means that alpha is to get alpha here, I'm going to get the inverse tan of root 3. Now we want to make sure that any angles here are measured in radians because they want the argument here ultimately measured in radians. So if we put that into the calculator, now on the calculator, if you have your calculator in degree mode, that would be 60 degrees. But in radians, that's equivalent to pi over 3. So that's what alpha is. But it's theta that we want. So this angle in here is alpha. That's pi over 3. So like that's 60 degrees there. So to get theta, it's going to be 360 degrees minus 60 degrees. So it would be 300 degrees. But again, we want it in radians. So theta is going to be here. Theta is going to be 2 pi radians, which is a full revolution, minus then that pi over 3. So it's 2 pi minus a third of pi really, which is 5/3 of pi, or 5 pi over 3. So that is one of the things that we need. So theta here is 5 pi over 3. That's one thing found that we need. The other thing though is the argument, right? So let's get that now. So this is the argument, the length of my hypotenuse there. So given that it's a right angled triangle and I have two sides already, to get the third side, let's just use Pythagoras. So we can say here that r squared is equivalent to 2 squared plus 2 root 3 to be squared. So then that's going to equal 4 plus, so when you're squaring this, you've got to square the 2 and square the root 3. So that's, if I square the 2, I'm going to get 4. If I square root 3, you just remove the square root. So then r squared is going to equal, that's 4 plus 12, which is 16. So then r is the square root of that, which is 4. So there's my modulus found. So now to answer the question, they want it in polar form. All we've now got to do is fill in our r and theta there. So to answer the question then, v, which was in rectangular form, it was 2 minus 2 root 3i. But now in polar form, what it is 4 times cos 5 pi over 3 plus I sine 5 pi over 3. And that's B part 1 done. Now, so B part 2 then, it says, okay, using your answer to B part 1, to find the two possible values of W where W squared is equal to V. Give your answers in the form, well, in rectangular form. Right, so, okay, so we start off with the fact here that W squared is equal to V. Now, if W squared equals V, then you could say that W is the square root of V, or you can say this. You say that W is V to the power of a half. So when you're raising something to the power of a half, you're getting the square root of it. So now we have to use our answer to B part 1 to do this. It can be done another way, but we have to use this result. So that's really telling us that we're going to be using de Moivre's theorem later on here. So let's replace my V here with what I got it to be earlier. So it's going to be then, it's going to be 4 times cos 5 pi over 3 plus I sine of 5 pi over 3. And that's all going to be then to the power of a half. Now, so what we have here now is a situation where we have two things multiplied by each other, all raised to a power. So we're going to have to raise each of them to that power. So we're going to be saying here it's going to equal 4 to the power of a half by all of the rest of it to the power of a half. Now, so what we really have here is we have a number in polar form raised to a power that's between -1 and +1. So what de Moivre's theorem says is you just multiply the power by the angle. But we're not going to do that just yet, because that power there is it's a number that's between -1 and +1. So what we're going to do instead is we're going to write this in general polar form before then using de Moivre's theorem. So anyway, 4 to the power of a half anyway, that's the square root of 4, which is 2. Now, before we use De Morgan's theorem here, as we were saying, we're going to write it in general polar form. And all that involves doing is adding 2n pi to the angle. The only reason we have to do this here is because that power, as we were saying there, is a number between -1 and +1. So what I'm doing here now is just adding 2n pi to the angle. And this is what we call general polar form. So it's now then that we're going to be able to use De Morgan's theorem, which, as I was saying there, just involves multiplying the power by the angle. So, which I'll just actually write down. De Morgan's theorem says this, so you're going to have like cos, if I've got cos theta plus I sine theta, and I'm raising that to the power of n, that's going to equal cos n theta plus I sine n theta, and that's De Morgan's theorem. So we're going to use that theorem now. So then we're going to have here, so W is going to equal then twice, so we're going to multiply the power by the angle. So when we multiply this by a half, it's going to become the following. It's going to become cos of, so when you multiply that fraction by a half, you just multiply its denominator by 2. So maybe I will, so it's going to be cos of 5 pi over 6 here, plus, when you multiply this by a half, it's going to become n pi. Plus then, I is going to be exactly the same thing over here. So I sine of 5 pi over 6 plus n pi. Okay, so now the hard work's behind us. Now all we have to do now is just sub in 2 consecutive values of n, because we're looking for 2 solutions here. So what we'll do here, we're going to just choose any 2 consecutive integer values of n. Let's go with 0 and 1. So let's replace n first of all with 0. So my first solution then will be 2 times cos of, well, when n is 0 there, that's gone. So it's just going to be cos of 5 pi over 6 plus then I sine of, again, 5 pi over 6. Then, now they want the answers in rectangular form, so that's what it is really in polar form, but we want to actually work these out. So cos of 5 pi over 6, if you're working that out on the calculator, make sure your calculator is in radian mode. But what you're going to get is minus root 3 over 2. Sine of the same angle is going to be a half. So then, just multiplying both of those by 2, you're going to end up with minus root 3 plus I. So that is one possible value for W. That's one of them found, and then let's find the other by this time replacing n with 1. So we're going to go back to this line now and replace n with 1. So when we do that, W is going to be then, it's going to be twice cos of, so when n is 1, it's going to be 5 pi over 6 plus, well, 1 pi, or just pi you could say, plus I sine of the same angle. So then, so 5 pi over 6 plus pi, well, that's like 6 pi over 6, so 5 pi over 6 plus 6 pi over 6 is 11 pi over 6, so it's going to be twice cos of 11 pi over 6 plus I sine of 11 pi over 6. And again, we don't want to leave the answer like this, we want to work the values of these out. So cos of 11 pi over 6, if you do that on the calculator, you're going to get root 3 over 2. And sine of the same angle is going to give you minus a half. minus a half I. So again, just multiply both of those by 2, and you're going to get root 3 minus 1I. So that's your second solution. So there are your two solutions to that in the form that they want, in the form A plus BI. And that is question 5 completed.